Hi everyone. Good morning. I'm still sick, so you can hear my voice is not so good. Oh, sorry. Okay, so today is Friday. Um, so today we will finish the two examples of 8.2. Then we will start 8.3. Um, your homework 8.1 and 8.2 and quiz 2 is due next Monday. Okay, everybody? Sorry. Okay, so let's continue. So last time we talked about the graph of um, secant and cosecant. Do you still remember, everybody? The graph of all the six trig functions. Use body language. Okay, move your hands. Sine, cosine, they are waves, right? Sine start with 0, and they go up, down, back up, right? And then cosine, they start with 1, they go down, they go up. And the period for sine and cosine, they're both 2 pi. Therefore, the 5 key points spreads evenly over the 2 pi period. That's why you get 0 pi over 2, pi, 3 pi over 2, and pi. And then tangent and cotangent. The graph of tangent looks like x cubed. Yes, everybody? And the period is pi. So you imagine the interval from minus pi over 2 to pi over 2. You divide it into 5 pieces. 4 pieces. So you have 5 points over there. And the y values, they are undefined, -1, 0, 1, and undefined. The tangent, cotangent is you flip the tangent upside down, which is like this, over from 0 to pi. Right? And you also separate this interval into 4 pieces, so you get those 5 key points. Do you still remember, everybody? Okay, so last time we talked about secant and cosecant. Secant is the reciprocal of cosine. So you draw the cosine and you flip it over. So the secant and cosecant is up, down, up, down. Okay, so how do you flip it over? 1 over 1 is 1. 1 over 0 is undefined. 1 over negative 1 is negative 1. 1 over 0, undefined. Yes, everybody? So after you draw the graph, the theta is still the same because the period is 0. If the period is 2 pi, same as sine and cosine. So sine, cosine, secant, cosecant, the period are all 2 pi. The tangent and cotangent, the period is pi. So that's why you can find the y values. Next class, Monday. I will print out these sheets and you're gonna fill those out. So also fill out these values. You're gonna be familiar with this common angle values all the time. Okay, so let's continue. Bless you. Okay, so we want to graph this. The methods very similar when we draw graph the 6 trig functions. We all construct the table with x, and then theta is the angle, or we say the argument. And then this one, the trig function involved is secant theta. The last column is the y. You see the y is 3 times secant theta plus 2. So the first step is set up the table. Yes, everybody? Let me grab the 6 trig functions. Set up the table. Okay, x, theta, and then it depends on the trig function. In this case, we're talking about the secant. So secant theta and then the y. Step 1, fill in the theta column. So this is why you need the sheet. The theta column is 0, pi over 2, pi, 3 pi over 2, and 2 pi. Is that okay, everybody? And then you fill in the secant theta column. What are they? Yeah, 1 undefined, -1 undefined, and 1. Yes, so make sure you follow the order. The common mistake is didn't put these values under the x. No, these values is only the theta, not the x. To find the x, you look at, okay, the theta is 2x plus pi over 3. Then you solve for x. How do you solve for x?
Take the theta, so 2x plus pi over 3,
Mm-hmm.
set it equal to theta.
Yes.
And solve for x.
Yeah, how do we solve for x? We want to get rid of the 2 and then pi over 3.
Subtract pi over 3.
Yeah, subtract pi over 3. So we get theta minus pi over 3 equals 2x. So then, yeah, divided by 2. So we get x. Okay, so x is theta minus pi over 3 over 2. Is everybody following? We look at the angle. Angle theta is 2x plus pi over 3. Right? And we want to solve for x. So how do we get rid of the 2 and the pi over 3? We subtract pi over 3 first and then divide it by 2. Yes, everybody? Okay. Now after we get the formula of theta, we plug in different values of theta. Here we plug in theta is 0. Right? So 0 minus pi over 3 over 2 is negative pi over 6. Is everybody okay with that? When you divide it by a number, it's the same as multiply by the reciprocal. But reciprocal of 2 is 1/2. So the 2, we multiply it in the denominator. Thank you. Okay. All right. So next, when we plug in theta, it's pi over 2. Pi over 2 minus pi over 3 over 2. What do we get? So don't forget to watch the recording for the first 10 minutes. We set up the problem. Okay. What is pi over 2 minus pi over 3? The common denominator? Yeah, very good. So that is, we multiply by 3, multiply by 3. Here, multiply by 2, multiply by 2. So you get 3 pi minus 2 pi over 6. And then you get pi over 6 over 2, which is pi over 12. So when you design the table, leave more space for the x. All right, next number, we plug in theta is pi. What is pi minus pi over 3? Yeah, 2 pi over 3. Over 2. What happened? Yeah. The 2 cancel pi over 3. Okay? So remember, you can use calculator to check your work. How? You don't type the pi in it. So you put 1 minus 1/3 over 2. Hopefully your calculator will give you 1/3. You know what I'm saying, everybody? Mm-hmm. You can use your calculator to check your work. But just don't type the pi there. Because for some calculator, if you input the pi, it just gives you a bunch of decimals. Mm-hmm. Okay, so next, the theta is 3 pi over 2, and we subtract pi over 3 over 2. So we are using this formula, and we plug in different values of theta. Okay, let's look at this. Common denominator is 6. So we multiply by 3, we get 9 pi over 6 minus 2 pi, and then over 2. What's 9 pi minus 2 pi? 7 pi. And over 6 over 2 becomes over 12. Is everybody okay with that? Mm-hmm. If you have questions, feel free to ask me. Okay, and next, 2 pi minus pi over 3 over 2. What is 2 pi minus pi over 3? 2 pi is what? Is common denominator is 3. And 3 times 2 is 6. 6 pi minus pi is 5 pi over 3. And then over 2, right? Yeah, 5 pi over 6. I would say the most difficult part of this table is the x column. Do you agree, everybody? Okay, so after you figure out the x column, you can find the y column. So the first one, we plug in secant theta is 1. So remember, it's the whole, secant theta is 1. So don't put secant of 1. So it's the whole secant theta is 1. And plus 2. What is that? 5. And when you plug in undefined, what do you get? Undefined. When you plug in minus 1, what do you get? Negative 1. Undefined? Undefined. 1? 5. Because it's the same as this number. So we figure out the table. Everybody okay with that? Thank you. Either way, when you do the homework of this session, because the homework is, you see the homework problems, they didn't ask you the whole drawing the graph of this. So they break the problem into a lot of small parts. Just ask you to find the amplitude, midline, or find the periods. But in the exam, your exam problems will be like this. You need to draw the graph of trig functions. So you're gonna set up the table and then plot the points on the xy plane and connect them smoothly. Everybody clear? So you have 3 problems like that in the exam. So one problem asks you to to draw the graph of either sine or cosine. The second problem asks you to draw the graph either tangent or cotangent. And then the third one asks you to draw the graph of either secant or cosecant. Is that clear, everybody? So 3 problems similar to this type. Okay, so that's the x-axis and the y-axis. Okay, that's the x, that's the y. And then you look at the x. The smallest value is negative pi over 6, right? The biggest value is 5 pi over 6. 5 pi over 6 is smaller than pi. Okay, so the biggest, I put pi, then it should be enough. And this is minus pi. Okay, so now how do we cut it? You know when the denominator is 6, it means you divide 0 to pi into 6 pieces. Oh, I pressed the wrong button. So you draw the pi first. You divide it into 6 pieces. Then the first one will be what? Pi over 6. The second one will be pi over 3. Next one, pi over 2. Next one, 2 pi over 3. Next one, 5 pi over 6. Are you okay with that? Because you divide into 6 pieces, this is pi over 6. This is 2 pi over 6, which is pi over 3. And 3 pi over 6 is pi over 2. 4 pi over 6 is 2 pi over 3. And 5 pi over 6 and the pi. Okay? So all these numbers are increasing. And the difference of them are fixed. What's the difference of them? Pi over 6. Yes. And then we also have negative values. So we cut it into 6 pieces. And then we get this point is negative pi over 6. All right, everybody? So we are ready. Now plot the points. The first point, when x is negative pi over 6, which is here. And then my y is 5. Oh, okay. I need, let's say 5 is here. And let's say negative 1 is here. So we get this point. Negative pi over 6, we get 5. Okay? And then pi over 12. Do you see pi over 12 is half of pi over 6? Yes? So half of pi over 6 is in the middle here. So this is pi over 12. And we get what? Undefined. The y is undefined. So we draw a dash line. So far, so good, everybody? Next one. Pi over 3, which is here. And we got what? Negative 1. Okay, negative 1 is here. And then 7 pi over 12. Where is 7 pi over 12? So 7 pi over 12 is exactly. Or you can think of the denominator. This one is between 6 pi over 12 and 8 pi over 12. Yes, 7 is between 6 and 8. And then 6 pi over 12 is pi over 2, right, everybody? And 8 pi over 12 is 2 pi over 3. So that's why you know it's between pi over 2 and 2 pi over 3. So this is 7 pi over 12. And we have undefined. So draw the little dash line. Last one. What is last one? X is 5 pi over 6. And then the y is 5. Yes, everybody? So now we connect the points up, down, up, down. So who's the upper point? approaching to the lines. So this is one period. Is that okay, everybody? This is one period. We plot the points and connect them smoothly. And in the exam, I will usually ask you to draw two periods. Then what do you do? Okay, think about this length, and which is right here. Okay, so you kind of approximate it. It's right here, and then you can draw like this, and then this. So for the second period, just approximate it. Is that clear, everybody? Yes? Mm. Okay, so let's continue. All right, this is problem number 5. Today I do want to start 8.3. So the last problem, I just want to talk about the ideas with you, so then we can start the next session. Is that okay? Because the last problem is a story problem. So yeah, everybody look at me. You can take notes after class, okay? But I want you to understand the concept, because when I prepare the notes, I prepare more examples. If we don't have time to cover all of them, then I would like to explain the idea so you can at least understand what we're doing here. And for the details, you can redo the problems or take notes after class. Okay? So here, a video camera is focused on the rockets on the launching pad 2 miles from the camera. So if you draw a picture, we have a rocket and then a camera. The distance between the rocket and the camera is 2 miles. Right? That's the first sentence. The angle of elevation from the ground to the rocket after X seconds later is pi over 120 times X. This is the angle of elevation. Yes? So the second sentence tells us that theta is pi over 120x. Yes? And part A, find a function expressing the altitude h of x in miles of the rocket above the ground after x seconds. Ignore the curvature of the earth. So h is the height, right, everybody? So therefore, we have the height, which is the opposite, and the 2 miles is the adjacent. Opposite over adjacent is tangent, theta. And we know theta is pi over 120x. So how do you solve for h? Both sides multiply by 2. Okay, everybody? If you can understand this step, raise your hand. Everybody understand? Okay, good. Now, part B. Graph it on the interval 0 to 60. Well, how do we graph it? Yeah, again, draw the table. X, theta, tangent theta, and then here y equals to tangent theta. Right? And what is your theta? Remember your tangent? Like this. And the angle is from minus pi over 2, minus pi over 4, 0, pi over 4, and pi over 2. And how about your y values? Undefined, -1, 0, 1, and undefined. Then you can find the x. See? X is, you solve for x, so you divide it by pi and multiply by 120. Yes? And then you plug in different theta values. You get the x values. Okay? And you plug in different tangent theta values. You get the y. So therefore, you plot the x and the y, you get a function like this. And you see, graph it out the interval 0 to 60. So 0 to 60 is just this piece. Okay, but it doesn't hurt to draw more. Okay, so 0 to 60, we have this piece. It's increasing. Part C, evaluate interpret the values h of 0 and h of 30. H of 0 is 0. This means at the beginning, the rocket is on the ground. Yes, everybody? And then after 30 seconds, the rocket is at 2 miles high, right? This is what it means. And then D, what happened to the values of H as X approaches 60 seconds? Well, X approach 60 seconds, you're approaching to the vertical asymptote. So the Y goes to infinity. Okay. So this is a application problem. But the idea we all learn, we learn how to graph, then we can look at the graph and figure out the rest. Any questions about this example? All good? So let's look at 8.3. Okay, so close that. 8.3. Yeah, this chapter is just 3 sessions, but each session covers a lot. So 8.3, inverse trig functions. All right. Do you still remember inverse function? Yeah? Okay, let's review all the basic concepts. Vertical line test. Vertical line test will intersect the graph of a function at most 1 point. So, which means, okay, if you have a graph like this, is this a function? Yes, it is a function. But if you have a graph like this, it's no, because the vertical line intersect multiple times. So this is not a function. Now, horizontal line test will intersect the graph of a one-to-one function at most 1 point. So therefore, in this case, horizontal line test. Is this a one-to-one function? Yes. So this is one-to-one function. But then, is this a one-to-one function? No. So this is not one-to-one because you can find a horizontal line intersected twice. So vertical line test tells us whether a graph is a function. And horizontal line test tells us whether the graph is a one-to-one. Okay, function. Then continue. Inverse function. So you have to have a one-to-one function. Then you can define the inverse function where you interchange the x and the y. And in terms of the graph, the one-to-one function, let me give you an example. So e to the x. E to the x looks like that. One-to-one function is we find the mirror image across the line y equals x. And you get the graph of this. This is natural log of x. Right? In college algebra or applied algebra, we introduce the inverse function and then we talk about exponential function and logarithm function. Right? Do you still remember? Okay, so summary of inverse function. For one-to-one function, each x value corresponds to only one y value, and each y value corresponds to only one x value. So that's why it's 1 to 1. You cannot have two x mapped to the same y. That's not allowed. If a function is 1 to 1, then it has an inverse function. We usually write it f inverse. Okay. The domain of f is the range of the inverse. The range of the f is the domain of the inverse because they switch the x and y. So your domain and range switch. Okay, everybody? The graph, they are reflection of each other across the line y equals x. And then to find the inverse function, we follow the following steps. We interchange x and y in the equation. We solve for y, and then the resulting expression, the y is equal to the inverse function. Okay, what does that mean? Let's find an example here. Okay, so how do we find the inverse function of this function? So this function, you have y equals x cubed minus 1, right? And this is the first step. We interchange x and y in the equation. Okay, so let's say this is first step. We interchange x and y. So when you see y, you write the x here. And when you see x, you write the y. Yes, everybody, interchange the x and y. That's your first step. And the second step, we solve for y. How do you solve for y? You want to get rid of the minus 1. How do you get rid of that? Yeah, we add 1 on both sides. We get x plus 1 is y cubed. So what is y? See? Yeah, you want to take the cube root on both sides, so the cube and cube root cancel, right? So y is x plus 1 to the 1/3 is the cube root of x plus 1. And then the last step, yeah, you can say now the inverse function is that expression. This is the third step. Okay, everybody? This is what it means. The resulting expression is the inverse function. So this is the 3 step how to find the inverse function. And here we can do that is because the function is 1 to 1. But what if the function is not 1 to 1? Like here, we all know parabola looks like this. It's not 1 to 1. So in this case, you're gonna restrict the domain so that you have a 1 to 1 piece. So we restrict the domain. Do you see now our domain x greater equal to 0? Now this piece is 1 to 1, right? This piece is 1 to 1. So this piece is like that, and it's 1 to 1. And so we can find the inverse function now. Flip it across the line, y equals x. We get this. Oh yeah. Yes. So the inverse function, okay, so you have y equals x squared, right? And you interchange the x and y, you get x equals y squared. And you solve for y. So when you solve for y, you get y is plus or minus square root of x. And because you restrict the x must be greater equal to 0, so you only get the positive piece. So therefore y equals only the positive piece because we restrict the domain to be greater equal to 0. Therefore here, my range, the y is greater equal to 0. We take the positive piece. By the way, this upper half is the positive square root of x. And the bottom half, if you want to draw the picture, right? It was like this. You put the whole thing, you get something like this. The bottom half corresponds to the negative square root of x. Is that okay, everybody? So if you don't have a 1 to 1 function, you can restrict the domain. So you get a 1 to 1 piece. Then you can find the inverse function. Any questions? so far? So this is what we learned before. Okay, now we use this knowledge to help us to find the inverse trig function. Okay, the first one is sine. Okay, do you all remember the sine graph? So sine is from 0 to 2 pi, go up and down, right? This is y equals sine x. Is this a function? A function. Is this a function? Yes. Is this a one-to-one function? No, not one-to-one. So we need to restrict the domain. So we get a one-to-one piece. The domain we restrict is the middle one. Right? We like to pick the piece that is near the origin. Therefore, the one-to-one piece we restrict is right here. Okay, that's why you see the where is it? They're both blue. How do you say the difference?
One's a lighter blue, one's a darker blue.
Okay, the darker blue is the sine x, which is this one-to-one piece. Yes, everybody. And then to find the inverse function, you flip it across the line. Y equals x. So therefore, your inverse function looks like that. And the domain and range, you're gonna swap. Okay, let's write it down. So we have the sine x, so domain. Let's say f is the sine x, and then the f inverse is the inverse sine x. So the domain of f. Now for sine x, because we restrict the domain, so it is 1-to-1. So the domain of f is negative pi over 2 to pi over 2. Is that okay? And the range of the sine, look at the sine. It goes from where to where? The y value. Negative 1 to 1. Right, everybody? That's the domain and range. Now look at let me use orange color. Look at the inverse function. So domain of the inverse function. Because inverse function flip the x and y. Your domain of the inverse function is the same as the range of the function. You see? The light blue, look at the domain. From here to here, that is actually from -1 to 1. Is that okay, everybody? So -1 to 1 is the same as this. And now the range of the inverse sine is gonna be like the domain of it. So negative pi over 2 to pi over 2. Your range, the y value, is from negative pi over 2 to pi over 2. So this is how we draw the inverse sine function. Or you can say x sine of x. They're the same thing. There's two different ways we write it. But be careful! Be careful! This is x sine, and this is not the same as 1 over sine x. So the negative one, we reserve the notation -1 stands for inverse function. It does not mean it's 1 over that function. Everybody clear? Okay, so what does inverse function mean? Inverse function, okay. Think about the sine x equals y. The x is an angle, and then the y is a ratio between the two sides of the triangle. And for the sine, that ratio is what? What over what? Oops. That ratio is opposite over hypotenuse. Yes, everybody? Now the inverse function, what does that mean? Now my x, is my x an angle? No. The x is like the y in my sine function. The x of the input of the arc sine is actually the ratio. It's the hypotenuse over opposite over hypotenuse. And then the y here is the angle. That's why the outcome is an angle, okay, in radian. Any questions so far? So gotta be careful what it means. What's your input? What is output? For inverse function, the input is a ratio, it's a number, and then the output is a angle in radian. Okay. So from now on, this chapter we use radian. We don't use degree anymore. Okay. So usually we just use radian. Okay, that is the inverse sine function. Note on the graph, the inverse sine function is increasing and continuous on the domain. You see the light blue curve is continuous. That means you draw the picture without lifting your pencil from the paper. And it's increasing. It's going up from the left to the right. Both the x and y intercepts are 0. Yeah, they pass through the origin. So x and y intercept are 0. And oh, did you see this guy? It's symmetric with respect to the origin. Yes, everybody. Therefore, it is an arc function. Yes, the light blue curve, symmetric with respect to the origin. You give me any point, and then you rotate 180 degrees about the origin. The point is also on the ground. The symmetric with respect to the origin is an arc function. Okay, now how do we evaluate the following? Okay, so there are two ways to evaluate this. One is use the unit circle, and then the second way is use the graph of the sine. I like to use the graph of sine because if you use the unit circle, usually you just see the x coordinate is the cosine and the y coordinate is the sine. But what happens to other transformation? You have to do more. But if you look at the graph, you know the graph of all 6 trig functions. Right, everybody? So I will teach you how to use the graph to find the following expression. By the way, all these problems find exact values means, can you use your calculator? No, you cannot use your calculator. So how do we do it? Okay, we draw the picture. So draw the picture of the sine. So draw a big picture of the sine. And let's say here is pi, here is 0, here is negative pi. And then we go up and down. Oops, sorry. Let me draw better. Go up and down. And then this is negative pi over 2. This is pi over 2. That is 1 and negative 1. Is that okay, everybody? That's the sine. And to find the inverse cosine, oops, sorry, we know the inverse cosine, the angle, we restrict to the 1 to 1 piece. That's from minus pi over 2 to pi over 2. Okay, now, how do we start? Okay, do you still remember the common angle values? They are what? They are pi over 4. Pi over 4 is in the middle of pi over 2. Yeah. And pi over 6 is you cut this into 3 pieces. So then this is pi over 6, and this is pi over 3. Yes, everybody? And remember our table. Sorry. Do you remember this? Uh-huh. So sine pi over 6 is what? 1 half. Sine pi over 4 is what? Root 2 over 2. And sine pi over 3 is... yeah. Let me drink some water. Okay. Yes. Now let's start. So have this picture in mind. Let's start. Okay. Here, x sine of root 3 over 2. So keep in mind that x of the x sine x, it corresponds to the y of the sine x because they are inverse functions. X of the this is the input of the x sine corresponds to the output of the sine. Is that okay, everybody? This is very important. Look at me and take notes. Mm-hmm. So this means if if we have y equals root 3 over 2, we want to find the x in the angle minus pi over 2 to pi over 2, such that it maps to that. So therefore, you set the y, see, the y is root 3 over 2, and then you find the x. Do you see this point? What's your x? Pi over 3. And you check, is pi over 3 within this range? Yes. So you set the y value equals root 3 over 2, and then you find the corresponding x in the range. So therefore, we get x is pi over 3. Is that clear, everybody? How we get it? You draw the graph of sine. And then imagine the input of the x sine corresponds to the y, the output of the sine, and you get that. Okay, let's do more. How about x sine inverse of negative 1/2? Now it means your y is negative 1/2. Right? And we want to find the x. Where is negative 1/2? In the down there. Right? This is negative 1. This is negative 1/2. And you find the x. So you draw here and find the x. Look at this picture. Do you see this negative 1/2, right? Do you see the picture is very similar to this one? So when x is 1/2, this is pi over 6. So when y is 1/2, the x is pi over 6. If y is negative 1/2, what's your x? Exactly. So draw your picture bigger. You get negative pi over 6. So you get x is negative pi over 6. Okay, sorry, let's finish this part. And last one. Root 2 over 2. You see? The y is root 2 over 2. What's your x? Yeah, your x is pi over 4. Okay. And last one. Can it be square root of 2? Can the y be square root of 2? No. So this is undefined. Okay? Because the y is only between minus 1 and 1. So we will continue next class. Have a good day and good weekend. Let's still start working on your homework. Bye.
I made the connection.